All right, so this is just practice. Let's see if I can get this so that it's situated properly. So between the videos that I created on February 27th, 24, between binomial squaring and getting up and running with logs, there are 10 questions that I can ask. And so to check the skill level, see if you're moving along nicely with those, I thought I'd do one from each video. And if you don't get it right, I suggest you go back and spend some more time with that video or ask questions in class so that keep an eye on those problems on the worksheets until you master them. All right, so squaring a binomial, you can check it later by doing parentheses times parentheses, but we're taking the shortcut. Squaring the 5, 25, doubling that product is 20i. It's going to be 40i here. Squaring, whether it's plus or minus, squaring is going to get a positive. In this case, 16i squared. And that, of course, becomes 25 plus 40i minus 16. There's your sign changer, I squared, changing the sign of the coefficient. Final answer, 9 plus 40i. I've seen that a lot on my worksheets. I must have a reason for using those numbers. I don't know what it might be. All right, next video talked about simplifying 5i to the 47th. I like to take the approach, non-textbook approach of I squared. Gotta be careful here, 23 times. That gets me to 46 times I gets me to 47. I like students. I'm giving you this because I think it also attacks the rules of exponents. Multiplication and addition, that's to the 1. Right, so I think that's really important. I also think it's important for students to understand the use of a negative sign, and I'm not even going to write -1. I'm just going to put a negative sign there, and I'm doing that 23 times. A minus times 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 a minus. Do it once, it's minus. Do it twice, positive. Do it 3 times, minus. Do it 4 times, positive. 5 times, minus. Even times, positive. So used to putting the 1. 7 times negative, whatever. Odd number of negatives means it's a negative, right? 1, 3, so on and so forth. So this is a negative number times I. Your final answer is 5 times -1 times I, which is equal to minus 5i. That's what you should have gotten for that one. Got a lot of stuff there that didn't need to be written. All right, then we got conjugates. 3 plus 2i over 4 minus 5i. I'm going to shift that over here so I don't have to move anything. So we're going to do a little conjugate. And I hear that these are quite often on SATs. I don't know. I don't take them anymore. 3 plus 2i. I'm sorry. 4 plus 5i. I always make a mistake in a video. Make an oral mistake there. 4 plus 5i. So what's the conjugate of a plus b? A minus b. Right? Because when we multiply them together, we get rid of the middle terms. I will do all of this though. 3 times 4 is 12. Light went off. Can you still see nicely? I think so. We're going without lights. 3 times 4 is 12. 3 times environmentally important. Plus 15i. Plus 8i. 2i times 5i. 2 times 5 is 10. And I times I is I squared. So I didn't write the 10. 10i squared divided by, and we'll do the middle terms once, but never again. 4 times 4 is 16. 4 times positive 5i is 20i. Minus 5i times 4 is minus 20i. And minus times a minus is a minus 25i squared. That's where people make mistakes. Don't say I squared. Too bad. All right, I'm going to use the eraser now. What happens with I squared? It's -1. And when you multiply something by -1, the sign of the coefficient changes. Same thing here. I squared is what? -1. So the sign changes to -10. Now we're ready for our final answer because the middle terms cancel. 12 minus 10, 2. 15 plus 8, 23i. It's called a complex number. 16 plus 25, 41. 16. Go right back to the original. 16. Squaring that, 25. Wow, I wonder if there's a pattern here. I'll keep my eye out for that pattern. Maybe all I had to do was square that and write 41. Keep an eye on that. All right, speed graphing. In the video, I broke it up into two graphs. One, the linear mx plus b form, which you're all been indoctrinated with. All right, and the rate of 2x squared when x is 0 is flat. That rate is flat. This is going down at 12 to 1. So at 0, it's going to adopt that rate. So I'm going down at 12 to 1 right here. And I also know that a 0 gets me 5. So I have some knowledge just from what's presented. I always like to graph polynomials reading them backwards. I start at 5. I go down. And then 2x squared is going to do what? Bring me back up again. All right, so it gives you a little feel for what's going on. Yes, so we have a cup shape up. That's going to dictate. All right, now I like to do all of that without the y-axis, but it certainly is helpful. 0 gets us 5, and we know we're decreasing at that instant. And if you want to find out why, look at the video. All right, and so now all I got to do, write the vertex, I'm done. And I know it's a positive x value, so if I don't get a positive x value, I got a problem. And so I'm going to divide 12 by 4, and I know it's 3. But you're going to take a little longer by remembering minus b over 2a. Minus b, positive 12 over 2 times a. There's your a term, which was 2. And yes, it's 3. Then I like to throw it into the middle term, minus 36. I like to cut it in half and then add 5. And that's minus 13, and I'm done. Now, you take more time by putting 3 in. So you see the patterns emerge. 2 times 3 squared minus 12 times 3 plus 5 is the y value at the vertex. 18 minus 36 plus 5. Yes, we got the 2 to 1 ratio and they're opposite. So we darn well know 3 is correct. And that becomes negative 18 plus 5. And the more you do, the quicker you do them. That's speed graphing. That was one of the videos. Next. I've got to move a tape. Oh my God. No. Yeah, there we go. Come on, let's get this table out of here. All right, I'm back again. Finding the roots. All right, well, I know I'm measuring from 3. I know I got to move to the left and the right to get to some x. That gets me a height of 0. Roots are heights of 0. Okay, so I'm starting from 3. And I know I got to go up 5 units to get to 0. I know if I double something, I only want half of it. And I know if I square something, then I got to square root it. There you go. Those are the roots. All right, look at the video if you didn't get it. Let's do some sinusoidal graphing. All right, so I know a maximum sine curve max occurs at pi over 2. And I know I got to turn 1900 into pi over 2. And that's not hard to do. It's linear. So what's the equation here? I got to find the midline. Midline's 45. I got to go up and down 5 units. And I will, as I travel around the circle, I'll go up and down. 1, down 1, up 1, down 1, up 1, down 1. But I'm going up 5. So there's my amplitude. And I know that I want to squeeze the circumference of the circle into that parentheses. All right, so 1900 becomes pi over 2. Can I write that small enough? 1900 becomes, I guess I'll put the parentheses here, put the pi over 2 right there. All right, I think you can see that, I hope. And then I just got to talk about the change in angulars. The angular change to the change in the years. Well, the change in the years is easy to see. That's 124 years. I know how to write 124 at this stage. That's good, I do. And I am looking at 1 revolution from here to here. You know, 1 revolution brings me back to a max. And that's 2 pi. Once around the circle is 2 pi. So this is 1 pi 2 pi, 3 pi, 4 pi, 5 pi, and I'm done. All right, so that's that graph. There's different ways to write it, but that's one way you can do it. And if that didn't make sense, go back to the video that does 5 or 6 of them, get some practice. All right, now we got to do some sine and cosine evaluations. So we'll just do one of each. And if you don't get them, go to that video. All right, so let's look at how do you do the sine of, how about 19 pi over 3? All right, can you see that? I hope I'm copying this. Yeah, I did the last problem here. You should have been able to see that. All right, so we got a circle, not a bad one. All right, I'm breaking it up into 3 parts. Boom, boom, and each one's 60 degrees. Right, but this is a radius length measurement. If there's 3 in the top half, there's 3 in the bottom, which means that there's a total of 6 pi over 3 chunks, 6 60-degree chunks, which is 330. All right, and I got to get to 19, which means I could go around again. That would be 12 pi over 3. And I could do 18 pi over 3. 18 pi over 3 is simply this location right there. We start from here. 1 pi over 3, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 16, 17, 18. Boy, I could have done that right away. And then I got to go to 19, which is there. And then I got my 30, 60, 90 triangle. So that's a half. That's root 3 over 2. And that's 1. And the sine function is opposite to hypotenuse, which in this case is root 3 over 2, because the sine function in the unit circle is the y value. Now we're going to do, you didn't get that? Go back to the last video that is in between those two, and it's evaluating sine and cosine. Sine and cosine evaluations, I believe is what it's called. So you go practice it. Cosine, let's do the cosine, the negative 19 pi over 3. Let's go the other way. Circle, a little rotator cuff problem there. Oh, I never draw the XY axis because it interferes with the chunks. 1, 2, 3, 4, again 6, but now we're going this way. So that's going to be negative 18 pi over 3 right there. And we got to get to 19. So now I got to come up to the x-axis and I want the cosine. Well, the cosine is the width. That's a half. The sine would have been negative root 3 over 2 because I'm below the x-axis. There's the practice for that one. Last 2 problems that we're going to do. We're going to do the ln of 3/5 organically. And then we're going to look at the rules of logarithms. So this is the ln of 3, which is e to the 1.1. 5, we're just learning 1.6. And so that's ln of e to the 1.1 minus 1.6. And that's where your rules of logarithms are going to come from right there. All right, so that's the ln of negative 0.5. So that's the ln of e to the negative 0.5. And this is asking, what do you put on top of e to get e to the negative 0.5? Negative 0.5. All right, so where are the rules of logarithms? The rules of logarithms are division is equal to subtraction. ln of 3 minus the ln of 5. Which you can kind of see in the box here. And then you would just write 1.1 minus 1.6, negative 0.5. All right, so there's your one problem from each video. Wherever you had a problem, wherever you didn't get an answer, go look at the video. You got to start the conversation somewhere and you got to start your practice somewhere. And what we do in our class is we do 1 or 2 of those every day. And we're going to do them until May 15th because gaps are not allowed. So binomial squaring, type that into the channel, getting up and running, rules of logarithms, and all the videos in between those two where you can get help. Okay, so let me shut this down, get off my legs. Old guy here. All right, and we'll see you in class.